Hello students, today I am going to teach you a very important lesson in differentiation, and that is chain rule. How to differentiate of a function of a function. Chain rule means function of a function. Suppose if you differentiate x to the power n, we will get n x to the power n minus 1. But instead of x, if you get a function other than x, fx, then how to differentiate n fx to the power n minus 1 into differentiation of that fx. That function which is there instead of x, we have to differentiate again. Similarly, root x, we know root x is 1 by 2 root x, but instead of x, if it is other than x, function of x, suppose log x or sin x or cot x or any function e to the power x, so root over fx will be 1 by 2 root fx, same 1 by 2 root x, 1 by 2 root fx into differentiation of fx. Similarly, e to the power x is e to the power x, but if you get e to the power fx, it will be e to the power fx into differentiation of f of x. As for example, if we differentiate, suppose 3x plus 7 to the power 9, it is not x but function of x. So how to differentiate? As it is n fx to the power n minus 1, so it will be 9 3x plus 7 to the power 9 minus 1 is 8, n x to the power n minus into, you have to differentiate again the function which is there instead of x. We have to differentiate 3x plus 7, so it will be 9 3x plus 7 to the power 8 into differentiation of 3x is 3. So if you multiply, 3 9s are 27, so answer will be 27 3x plus 7 to the power 8. That is called chain rule, function of a function. Now if you get another function, suppose if you differentiation of suppose root over 3x plus 7. How to differentiate? Root over fx, so it will be root x is 1 by 2 root x, 3x plus 7 into, you have to differentiate again 3x plus 7, so 3x plus 7 will be 3, so the answer will be 3 by 2 into root over 3x plus 7. Similarly, if we differentiate log of sin x, log x is 1 by x, so log of sin x will be 1 by sin x into differentiation of sin x. We have to differentiate again sin x, which is cos x, so 1 by sin x into cos x, which is cot x. Similarly, we can differentiate many more functions which will be in chain rule. Next, number 4, if you get, suppose differentiate sin square x, so what will be differentiation of sin square x? Square. So power is first, sin square x, sin x whole square. So what is the differentiation of x square? X square is 2x. So sin square x will be 2 sin x into, we have to differentiate again sin x. So this will be 2 sin x into cos x. But if you get sin x square, differentiation of sin, suppose x square, angle is square, so sin x, we know differentiation sin x is cos x, so it will be cos x square into, you have to differentiate x square. So differentiation x square is 2x, so 2x we can write in the beginning, 2x cos x square. So this is called chain rule. We have to differentiate again the function which is there in place of x. Next, if we differentiate, suppose 10 cube x, 10 cube x, 10 cube, the power we have to do first, cube. So x cube, what is the differentiation of x cube? It's a 3x square. So 10x whole cube, so it will be 3 10 square x. 3x square. Here x is 10x, so 3 10 square x into, we have to differentiate 10x, which is there instead of x. So it will be 3 10 square, and the dx of 10x is 10 sec square x. So 3 10 square into x into sec square. So similarly, we can do more examples. So we are going to start chain rule of inverse trigonometric functions. So you have to know some formula. Differentiation of sin inverse x is 1 by root over 1 minus x square. Similarly, the dx of cos inverse x is minus 1 by root over 1 minus x square. The dx of tan inverse x is 1 by 1 plus x square. Differentiation of cot inverse x is minus 1 by 1 plus x square. Similarly, the dx of sec inverse x is 1 by x into root over x square minus 1. Cosec inverse x will be minus 1 by x into root over x square minus 1. Now we are going to prove one of this formula, how to prove differentiation of sin inverse x. Just say very simple. Let y equal to sin inverse x, where x belongs to open interval minus 1 to 1. So what will be x here? X equal to sin y. If y equal to sin inverse x, by inverse functions, definition of inverse functions, x equal to sin y. If you differentiate with respect to y, dx dy will be cos of y, and cos y is positive, so it will be root over 1 minus sin square y. Formula cos y equal to root over 1 minus sin square y, and sin y is x, so it will be root over 1 minus x square. So if you reciprocal it, dy by dx will be 1 by root over 1 minus x square. Hence we can say y is sin inverse x. So what will be the differentiation of sin inverse x? Differentiation of sin inverse x 1 by root over 1 minus x square. Reciprocal it. Similarly, if we do another one, differentiation of tan inverse x is 1 by 1 plus x square. Let us do tan inverse x is 1 by 1 plus x square. So if you solve it, prove it, let y equal to tan inverse x. So for all y, x belongs to real number. So here x will be tan y. If you define it with respect to y, tan y will be sec square y, and sec square y is nothing but 1 plus tan square y, and tan y is x, so 1 plus x square. If you reciprocal it, dy by dx will be 1 by 1 plus x square. So hence differentiation of tan inverse x will be 1 by 1 plus x square. Now we are going to find out some problems based on inverse trigonometric functions. As for example, suppose if you differentiate suppose tan inverse sin x. What will be the differentiation of tan inverse sin x? So differentiation of tan inverse sin x. What is the difference of tan inverse sin x? So tan inverse x is 1 by 1 plus x square. So x is here sin x, so 1 by 1 plus sin square into differentiation of sin x. You have to differentiate again. So differentiation of sin x is cos x by 1 plus sin square x.